Picture this. You're working a massive stadium gig. The crowd is roaring, and suddenly, literally minutes before the main act takes the stage, a massive black patch appears right on your main LED screen. Cue the internal screaming, right? The pressure is absolutely on. Do you know where to look first? I mean, is it a dead module? Is it a scrambled cabinet? Or are you looking at a full system failure? Welcome to This Explainer. Today we're taking those incredibly dense, complex engineering manuals and transforming them into your ultimate rapid diagnostic playbook. We're going to break down LED screen faults step by step so you can troubleshoot with total confidence and, most importantly, zero downtime.
Okay, let's dive into this. Our roadmap today covers diagnosis and indicator lights, pixel and line faults, module and color failures, cabinet and system issues, environmental and preventative care, and we'll wrap it up with a summary.
First up, Section 1, Diagnosis and Indicator Lights, because every single successful repair begins with reading the system's heartbeat.
Look, before you touch a single wire, you absolutely need a foundational procedure. It's 4 simple steps. Gather information, check your indicators and software tools, identify the root cause, and then, only then, apply the fix. For instance, say you've got a flickering screen. You don't just start ripping out power supplies and hoping for the best. You gather the info, trace that flicker, and you might actually discover it's an OE, an output-enable signal issue, rather than a power drop. Having this mental framework, it saves you from chasing ghosts.
Now, what's really interesting about this slide is that these simple blinking lights tell you almost everything you need to know about your receiving cards. If you memorize this exact table, you basically become a diagnostic wizard. Steady red, your power is good. A green flicker once a second means you've got normal operation. But if that green light slows way down to a crawl, like just once every 5 seconds or 0.2 hertz, you instantly know you've got a broken network cable or you've lost video input. On the flip side, a frantic 7 hertz fast flicker, that's a boot or license error. Just by reading the lights, your troubleshooting path is crystal clear.
Moving on to Section 2, Pixel and Line Faults. Once you know the system is receiving data, but the image is still messed up, we need to zoom our diagnostic funnel all the way in to the micro level.
We've all seen this, the classic dead pixel. The symptom is obvious, just a single LED completely off. So what's the cause? Usually you're looking at physical bead damage, a solder failure, or a pin failure on that specific LED. The fix is straightforward. You replace the LED bead itself. But here is a massive pro tip straight from the manuals. When you test that newly replaced pixel with your multimeter, you have to do just a quick touch. Your multimeter generates a small voltage to detect a closed circuit, and holding it on there too long can actually overdo the current. You could literally burn out the exact LED you were trying to test.
Next up is something engineers lovingly call the worm effect, or sometimes the caterpillar. You'll see this abnormal, continuous, bright streak running right down a column, and it's especially annoying on low brightness or black backgrounds. The cause here is an electrical short circuit or tin bridging. Basically, a pixel has failed open, pulled down the voltage, and now that whole line is constantly lit. To fix it, you've got to carefully remove the faulty beads, clean up the printed circuit board, and resolve that short so the current flows exactly how it's supposed to again.
Let's move to Section 3, Module and Color Failures, and see how this builds. We are scaling up slightly here, moving from those individual microscopic pixels to entire sections failing on a specific LED module. Now check out these 2 common faults. Visually, they look really similar, but diagnostically, they point to entirely different chips. If you've got a missing vertical column, your culprit is a driver IC fault. But if you're missing a horizontal row, you are looking at a 74HC245 or a 4953 logic buffer chip fault. In both of these scenarios, your fix is to check for short circuits, replace those specific integrated circuits, and repair any broken traces with the jump wire.
But what if exactly half of your module goes completely dark? It's a very specific, perfectly split failure. When you see this, the cause is generally a damaged 74H245 IC, a faulty first driver IC right at the failure point, or it could even be the wrong setting in your LED Studio software. To fix it, you either break out the tools and replace that short-circuited 74H245 chip, or you just jump into your software and correct the cable routing and configuration settings.
And then sometimes the module is on, but a specific color, say the entire red or the entire green channel, is just totally gone. When one color channel fails, it almost always means the data signal for that specific color is short-circuited somewhere, or, once again, that trusty 74HC245 IC has a fault. Finding and cleaning that physical short on the board or swapping out the IC is going to bring your full color spectrum right back to life. Okay, we've mastered the module level. Let's pull our diagnostic focus way out to the macro level with Section 4, Cabinet and System Issues.
And this brilliantly illustrates the difference in scale you need to keep in mind. You have to immediately contrast localized hardware failures against system-level software issues. A missing column on a single panel, that's localized. Go grab your soldering iron and swap a driver IC. But an entire cabinet showing garbled, scrambled nonsense, that's systemic. That means you've got the wrong firmware or a corrupted configuration file loaded onto the receiving card. You fix that with your laptop, not a hot air gun.
When the whole display fails, you really have to think system-wide. If the entire screen is all black, you check the mains power, you ensure you actually have a video signal, and you verify if the sending card itself has failed. If the image is disordered and fragmented across multiple cabinets, well, your physical cable routing probably doesn't match your software connection settings. And if the entire massive display is flickering, look, that is rarely a dead pixel. It points to poor network cables or a major voltage drop. The solution there is to reseat your main cables or just replace the main power supplies providing the voltage. Of course, the absolute best way to troubleshoot a fault is to stop it from happening in the first place, right? So let's look at Section 5, Environmental and Preventative Care. Moisture, extreme heat, and dust. These are the silent killers of LED screens. For your outdoor setups, you need to actively inspect your cabinets for water ingress right after a rainstorm and make sure you maintain those anti-corrosive coatings. Indoors, climate control is paramount. If you're setting up in a humid exhibition hall, anything above 65% humidity, you literally need to run dehumidifiers around the screen before you even power it on. And universally, always wear anti-static gloves. It is way too easy to fry an IC just with your own body heat. All right, Section 6, Summary. We've covered a ton of ground today, from the flashing indicator lights of a control card all the way down to the microscopic traces of a driver chip. Let's bring it all together. So, the crucial point to take away from this explainer is that troubleshooting LED screens is actually a highly logical process. Faults always live at one of four levels: the module, the cabinet, the system, or the environment. If you master your tools, reading those indicator lights, properly using a multimeter with a quick touch, and navigating your pixel mapping software, you are going to be unstoppable. Your solutions are going to range from executing a super delicate jump wire repair and replacing a 74HC245 logic buffer chip, to something as simple as swapping out a faulty network cable or plugging in a dehumidifier.
By structuring your approach and understanding exactly how the signal flows from the macro level down to the micro level, you remove all the panic from the equation. So I'll leave you with this. The next time you're on a high-stakes gig and that massive screen goes pitch black minutes before the show, will you know where to look first? Trust this new diagnostic framework, read the heartbeat of the system, and you'll be ready for absolutely anything. Thanks for joining me on this explainer, you guys. Keep learning and stay focused out there.